Eulers Theorem, or Eulers Theorem, depends on the pronunciation. Number one, we're given that the theorem is r e to the I theta equals r times cos theta plus I sine theta. We have to convert z equals 2 cos pi upon 4 minus I sine pi upon 4 into r e to the I theta. So what we have to do is to change this to a plus before we can do it. So we'll write this as z equals 2. Now this will be the cos of minus pi upon 4, because as you know the cos of minus pi upon 4 is the same as the cos of pi upon 4. And then we can write plus I, the sine of minus pi upon 4. And then to simply write that as z is equal to, the 2 is this here, that's 2, e to the minus pi upon 4i. Now you may recall that if theta is equal to pi here, right, and r is equal to 1, then, so I'll write that over here, so theta is equal to pi and r equals 1, we get that e to the I pi is equal to, this is 1, that'll be cos of pi plus I, sine of pi. Sine of pi is 0, the cos of pi is minus 1, and you get the famous result, either I pi is equal to negative 1. Done. Number 2, we have to use Eulers Theorem to work out 1 minus I to the power 4. And it's a really neat method. Before we can do that, we have to convert this into the mod arg form. That's the 1 minus I. And to do that, obviously, this is your minus, the theta is equal to minus pi upon 4. And your argument is going to be the square root of 2, as before. So we can say that 1 minus I is equal to, that's going to be the root 2, it's going to be cos of minus pi upon 4 plus I sine of minus pi upon 4. So that in the Euler form is going to be equal to root 2, and it's going to be e to the minus pi upon 4 I. So 1 minus I to the 4th is simply root 2 e to the minus pi upon 4 I to the power 4. Root 2 to the power 4 is 2 to the half times 4, 2 squared, so that's just 4. And multiplying these indices, you get e to the minus pi I as your final result. Done. Right, we have to solve this equation for x. Now to do that, we'll need to expand this bracket out here. And we need to be very careful, so I'll write that down as minus root 3 plus I times 1 minus root 3i. And now first of all, I'll multiply this bracket by the minus root 3. So it's minus root 3 bracket 1 minus root 3i. And then multiply this bracket by the I. 1 minus root 3i. You could use FOIL, but it gets a bit tricky with all these negatives. So here we got minus root 3 times this is minus root 3. And that will give me plus 3i. And here we're going to have plus I. And here we multiply that by that, we're going to get minus root 3. Or plus root 3, because I and the I will give a plus. You need to watch that. So it's plus root 3. And that simplifies down to just 4i. Now remember you're dividing by 4, so e to the ix equals 4i on 4, which is just I. So on the diagram, on the Allegrean diagram, you'd have I is just this one up here. So the argument would be pi upon 2, Okay, and the modulus will be 1. So e to the I x will be equal to e to the I pi upon 2. That means that x must be equal to pi upon 2. Done.